Assalamualaikum and a very good morning to our channel. My name is Azryl. I would like to present my final year project proposal. My project title is Mechanical Properties of PLA HA Type Contribute Cylinder 3D printing Process. This is my personal background. My name is Azryl Nazmin bin Mohammed. My student ID is 2019268378. I'm from Group MBI 2. My supervisor is Dr. Farashada Muhammad Saleh and my co-supervisor is Dr. Izia Taraji. Here is my content for my proposal. First is project summary, number 2 is project background, number 3 is methodology, and lastly is expected result. This is my project summary detail. The use of polyethylene acid PLA filament in 3D printing process is becoming widespread because the filament is a recyclable natural thermoplastic. Polyester that derived from renewable resources such as cornstarch or sugarcane. Although PLA is environmentally friendly, PLA exhibits low thermal resistance compared to other printing materials and may not meet the mechanical requirement of our application due to its moderate strength property. PLA part may function adequately for less demanding applications but should be carefully considered when higher functionality is required. To overcome the disadvantage, the combination of PLA and hydrous appetite HA composite give a good result to the mechanical properties of the filament. The result, combination of PLA and HA are used for medical applications where it meets the condition in repairing the bone. For this research is to make a filament for 3D printing which combination of PLA, HA and fabrica starch TS. The mixing or blending will be conducted to prepare the three feedstock composition. Three mass composition is used such as 75-25, 70-20-10 and 65-20-50 weight percentage for composition ratio PLA-HA-TS. Then filament will be produced through pre-extrusion process which optimal process parameter which temperature 180 degrees Celsius at speed 30 rpm. After that, all type of composition will be tested via mechanical properties such as tensile test. This is the project background. First one is introduction, second literature review, number 3 is objective, and lastly scope of the project. The introduction. In last few years, polyethylene acid PLA become more popular as a biodegradable and lightweight thermoplastic polymer. It because that this group of polymer undergo a degradation process in which they are break down into components that are transformed in the metabolic pathway avoid harm the environment. Hydrous appetite is categorized as a bioactive, non-toxic, osteoinductive, and osteoinconductive ceramic of great importance for bone scaffold due to its close analogy to the mineral portion of bone and teeth, and its capability to create direct chemical bond with living tissue. During this contact, the mix of PLA with HA might lead to polymer composite which accumulated level of bioactivity and regeneration potential for bone tissue in marine. The use of tapioca starch as bioplastic are limited because of hydrophilic nature, brittleness, thermal instability, as well as a high production cost and large area of land needed to produce bioplastic. This research major objective is to look at what happened to the PLA-HA composite filament after tapioca starch is introduced to the mix. The mechanical properties of these composites such as tensile are the key of the finding. Literature review. Number 1. Multi-purpose oligomeric compatibilizer for PLA and starch composite are made using recycled PLA. The resulting amphibolic product were evaluated as potential PLA and starch compatibilizer. According to several methods, the generated oligomer strengthened and improved interfacial adhesion which raised the compatibility and flexibility of extruded and matte blended PLA and starch composite. The developer one pot method made scaling simple because neither a solvent nor catalyst were required. In single pot, PLA could be transformed into additive which reduced molecular weight. When polyol including glycerol, sorbitol, glucose, and starch were present, PLA was subjected to conditions that cause thermal degradation. In order to produce PLA oligomer containing the polyol and group, polyol react with PLA chain causing an increase in PLA breakdown. In PLA composite containing 40% starch, this PLA oligomer with several hydroxyl and group may be used directly as compatibilizer. They were able to successfully raise the composite compatibility and mechanical performance without compromising their thermal stability. When it comes to the four compatibilizer, LLGLY is the most favored for producing composite with a high stress at break and adequate strength at break. Literature review number 2. Fabrication and mechanical properties of PLA-HA composite in medical. According to previous research about PLA-HA composite research, J research in 2021, the amount of HA in the calcine HA composite has had a significant impact on their elastic modulus. And figure 1, as previously tested having mechanical quality that are similar to those of the bone tissue that they are intended to replace is one of more crucial requirements for an ideal bone substitute, in particular those that are to be utilized for load-bearing application. The mismatch of elastic modulus with surrounding bone and the subsequent stress shielding that result in tissue necrosis leading to osteoporosis and implant failure are two major factors that limit their life of current metallic implant, making matching the elastic modulus as have been able to achieve here extremely important. Literature review number 3. Mechanical properties of tapioca starch film plasticized with glycerol and sorbitol. SMM Zahiruddin in 2018 making research about plasticization to tapioca with glycerol plasticized film, sorbitol plasticized film, and glycerol sorbitol plasticized film. Plasticizer were added, however, the TS value dropped due to interaction between plasticizer molecule and starch polymers, which weaken hydrogen bond and increase molecular mobility of the polymer metal. The addition of plasticizer decreased the tensile strength of the film. The improvement in flexibility and elongation of the film as a result of increased molecular mobility between polymer chain made the film less brittle. The objective. Number 1. To prepare various PLA-HATS feedstock composition. Number 2. To analyze the rheological properties of filament made of PLA-HATS. Number 3. To study the mechanical properties of PLA-HATS filament through tensile tests. Scope of the project. Number 1. 3 samples of missing procedures using various feedstock for each composite will be provided. Feedstock strategy will be separated into 3 parts. For the 20% sample of missing process, the amount of HA will be the same. To create a proper mixture, the portion of PLA should be 75%, 70%, and 65%, while the portion of tapioca starch should be 5%, 10%, and 15%. A series of mechanical tests will be conducted, such as tensile tests. The methodology. Number 1. Material characterization. Material characterization will be performed on PLA, HA, and tapioca starch. Among the material characterization analysis carried out were that of phenometer density, particle size distribution, thermal analysis, and morphology analysis, PLA, HA, tapioca starch. Number 2. Mixing and blending. The different PLA-HA tapioca starch composite kind will be made for this experiment. One composite contains a whopping 75% PLA-HA at 20% and tapioca starch 5%. After it, 70% of PLA-HA at 20% and tapioca starch at 10%. In addition, 65% of PLA-HA at 20% and tapioca starch at 50%. The planetary mixer will be used to blend this material at a speed 30 rpm and a temperature of 180 degrees Celsius. Rheological test is number 3. The behavior of the PLA-HA tapioca starch composite will be studied using rheological test with feedstock flow viscosity of 100 to 1000 Pascal. Lower viscosity when MFI is high but molecular weight is low, the highest reinforcing effect and the lowest brittleness are the factor to be investigated for pseudoplastic behavior which occur when in between 0 and 1. Number 4 is tensile test. A twin screw extruder machine will be used to produce the filament for the PLAHA composite material. Screw speed is set to 50 rpm with 16 diameter. The die temperature is fixed 180 degrees Celsius, while the operation temperature for the barrel is 170% degrees Celsius. The filament is generated with 1.75 average diameter. The filament will be net be examined with jig to ascertain its mechanical characteristic by using STM DC38 type IB standard tensor test with a 5 kilonewton load cell. The filament will test at various displacement rates, including 550 and 5 per minute using grid during the testing. Filament length is set to 200 where it's being clamped. Expected result. The fact that each filament produced by extraction will have a different result when it contains three different compositions in terms of weight percentage. Since the Becasta has known properties, adding it to the PLA and HA composition will cause all reactions to be investigated in order to ascertain the meteorological characteristics. Lastly, the mechanical properties such as tensile test and flexural test of the composition will be evaluated after the extraction process. This is the expected result for the tensile test we get when we use tensile test. That last for me. Thank you.